Our last bit here is we're going to take a little look at the root test, which is sort of appended on to the ratio test. I think you'll see why here in just a bit. The root test says that suppose we have a series, and what you compute is this. You compute the limit as n goes to infinity. We want absolute value of an. So if this is alternating, the absolute value takes care of that. But then you compute the nth root. You compute the nth root of the a sub n term. So you compute the nth root. Remember that this, and very often it is the way to think of this is you change this to exponential form. This is not always the case, but very often you'll rewrite this as we have absolute an, and we have this raised to the 1 over n power. And you'll see why when we go through a few examples, why it's actually sometimes more convenient to write it this way. But then this, once again, will become one of three things. And the conclusions here, the three categories, they're precisely the same as the ratio test. That's why this gets appended on to the end of the ratio test. One possibility is if this is less than 1, then it converges. If this is greater than 1, it diverges. And if it's equal to 1, then there's no information. And so the conclusion rules are the same as for the ratio test. It's just you're computing the nth root. Now the key is this. Typically this is used if you have n raised to the n in some form or fashion. If you have n raised to the n, or if you had n plus 3 raised to the n, or if you had 2n plus 1 raised to the n. If you have the n raised to the n in some form or fashion, then very often the root test is going to be the tool that allows you to do this, to determine if the series converges. So we'll take a look at a specific case here, and the computation is pretty straightforward. Remember that if you write this with exponential form, it actually shakes out pretty straightforwardly. So let's suppose our series is, what do we have here? Let's go 4 to the, let's say this is 2n. Let's do that in the denominator. I'm going to write that. 4 to the 2n divided by n raised to the n. So here we have n raised to the n power. That means this is a pretty good candidate for using the root test. And there are no guarantees in any of this, but that's the first pitch you want to make, is if it's n raised to the n, the root test is the first throw to make. So we have the limit as n goes to infinity. We need the nth root, and again, absolute value. So if this were alternating, the absolute value would take care of that, guaranteeing that we don't have negatives inside this radical, because if n is an even number, you're not allowed to have negatives inside here. The absolute value takes care of that for us. So in this case, it doesn't matter because everything is positive. Okay, so I'm going to rewrite this. I may forego the absolute value because nothing is negative. And I'm going to write this as 4 raised to the 2n over n to the n, and raise this to the 1 over n power. Sometimes it's a little easier to see if you write this in exponential form, because when you raise a power to a power, you multiply. Top times top, bottom times bottom. So this becomes the limit of 4 raised to the top times top is 2n, bottom times bottom is just n, over, and then this is n raised to the top times top is n, bottom times bottom is also n. And now we can simplify that, and you see what happens. By using the nth root, we get rid of these n power and the exponents here. And so what do we generate from all that? We're going to get that's equal to the limit. And this is 4 squared. And this is simply n. And we don't really need to, but just for completeness sake. And as n goes to infinity, that clearly goes to 0, which is less than 1. Therefore therefore this converges. Spell it correctly. All right, so it's very straightforward, and using the root test, again, it's a relatively limited field where it would typically apply, but when it does, it's exactly the tool that we wanted to use. This was n over n. And so it gets rid of these exponents, and the computation works out pretty straightforwardly.